Hi, I'm Dr. Sarang. In this short video, I will introduce you to H2O. Now, before I start on H2O, let me define who is the expected audience for this talk. This talk provides a high-level overview of H2O framework and yet gives a broad coverage to build the expectations of seasoned developers, students, and also the people in the executive management cadre. Just a piece of warning here. The presentation contains technical stuff and I expect that the audience has some knowledge of machine learning. I also use Python in explaining few examples. So what is H2O? Before I answer this question, let me ask you few questions. Have you ever developed an email application? And if so, what is the process? Let me describe a scenario here. Consider a large superstore like Aldi's would have collected a huge database on customer purchases over a period of time. Now they would like you to analyze the data so that they can discover the customers' habits to boost their sales. You will be surprised that in a similar case it was discovered that the dads who bought diapers also bought beers at the same time. This sounds funny, but it is a fact. Thus, stocking beers next to diapers would increase the store's sale. Now let me describe you the process of developing such application. I will first describe the traditional way for data analytics. You will start with the database, apply some well-known statistical methods to it, develop a statistical model, and when satisfied with the model, you will deploy it and put it to the production use. But this is definitely not the machine learning. This is the old technique of data analytics. So in machine learning, what we talk about is neural networks. We talk about supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, deep learning, and the latest thing is GAN. So the list continues further. Now there are hundreds of algorithms and techniques available for training the machine. In machine learning, you train the machine and there are many algorithms and techniques available for training the machine. It is so exhaustive that you may require few months or even years of dedicated learning to master this. So, does anybody provide me a ready-to-use solution? Of course, the answer is a big no. So, why should you spend time in reinventing the wheel when people have already developed so many machine learning algorithms? Though H2O does not provide a ready-to-use solution for your business, it does provide lots of pre-implemented, fully tested ML algorithms for trying out on your database. Here is a quick list of what H2O provides. There are several popular machine learning models that you can try out on your database. What H2O provides is several weight-tested machine learning models such as gradient boosted machines, GBM, generalized linear model, GLM, deep learning, and so on. Most importantly, it also supports AutoML. I'll talk on AutoML toward the end of this course. So, the question now is, how do you develop ML applications in H2O? To answer this question, I will describe the three processes that you would typically follow in the development of machine learning models. First, let me talk about the traditional way of developing the machine learning applications. You start with a database, use a machine learning model, check its performance. If the performance is not satisfied, do a fine tuning on the model, check the performance again. If not satisfied, iterate again. And finally, when satisfied, you put it to the production use. This is a traditional way of developing the machine learning models. Now, you also talk about a multi-model process. Now, in multi-model process, rather than trying out one single model, you may like to apply different models on the same database and check its performance. So, what we do in multi-model process is you start with the database, you take first machine learning model, check its performance, take another machine learning model, check its performance, take the third model, check its performance. Now you will select the best out of these three and then take that to the production environment. Now the next process that comes is AutoML. AutoML simplifies this selection very easily. So what you do is you start with a database. You tell the machine that I want to test out 18 different models on my database. So let the machine do a performance checking on all these models. So it will take machine learning model 1, 2 and 18 and so on, and it will compute the performance of all these models. Then the next thing is we ask the machine to provide us the ranking on the performance of these models. Out of this, here ML7 is ranked at the top. So we take this to the production and that's it. So that is how the AutoML will simplify your machine learning model development. Now exactly this is what H2O is capable of. It has lots of things in its offering. Before I go further, I would like to mention a few facts. H2O is used worldwide by more than 18,000 organizations. It supports R and Python for development. It provides an in-memory platform that provides an outstanding performance on even big data. Now, I will go a bit technical. As I mentioned in the beginning, this is where you would be exposed to some Python code. You can do H2O development in Python, in R. It also provides a GUI called Flow for the development. It also supports developments on big data such as Hadoop and also Anaconda Cloud. Now let us look at the actual development. This is a simple Python application. First we import the H2O library. I am going to use the random forest estimator in this code. So I import that library H2O random forest estimator. We initialize the system. Then we load the data file iris.csv, which is a very popular database used in machine learning. The 4 columns which I use as features are sepal length, sepal width, petal length and petal width. The output is the class column. Then I split the data into 80-20 ratio. I use 80% of the data for training and 20% for testing. Then we build the model by calling the H2O random forest estimator with few parameters like the number of trees, the maximum depth, the number of folds and so on. Once a model is built, we train the model using the train method. Then we check the performance of the model by calling model performance. Then we print the performance here. The output would be something like this, which shows you MSE, RMSE, log loss, this. It also gives you the confusion matrix. Now, I can change the algorithm in this code very easily. This is the new code where only 2 changes are required in the original program to apply a different machine learning algorithm. The first change is I import the appropriate library here, package here, which is gradient boosting estimator. And then I create a model using this gradient boosting estimator. I train the model, I check the performance, and so on. The rest of the code remains the same. Now again here I will check MSC, RMSC, log loss, and the confusion matrix. Now out of the two algorithms, I will check which one is better and use that in my production environment. H2O does not stop here. It allows you to use AutoML for the model selection. I import the AutoML library. I construct my model using H2O AutoML, where I say the maximum models I want to evaluate is 30 and the maximum runtime is 300 seconds. I want to run this code. Then I train the model. After the training, it will automatically create the leaderboard. So I call the leaderboard here and I print the head of the leaderboard, which would be something like this. Now it shows me the one at the top is the one which has the least error. So I use this, and the corresponding algorithm is this. So out of the 30 algorithms which I have tested, this is the best performing algorithm on my data set. Now I can use that algorithm into the production environment, or I can put it for testing by calling predict on the test data and get the results here. If the results are satisfactory, I can take this to the production environment. Isn't this interesting? Are you not excited to use H2O now? If you like this tutorial, please visit our academy for more such courses.